Hello there, students. Mr. Zana here with your next Ed Puzzle lesson. Today we are investigating tectonic plates and how their movement creates different land features. We are going to, through a discovery lab, which I call the food lab, we're going to be taking notes in our ISN, so I hope you brought those, and we're going to be doing a worksheet to extend our learning. So this is important to understand the way our Earth was formed around us and continues to change over time. So here we go with the unit organizer. Right here is our date that we're working on. And so we're right here. We're still dealing with plate tectonics, all right? And here is dealing with boundaries, all right? So we are going to be talking today more about our plates and how they're formed. So as we go along, you'll see here it says, under each, write what evidence was used to support the theory. Why did they think this was happening? So continental drift and seafloor spreading we covered in our last lesson. And as I explained to my students, you need to be keeping up with this. Every time we have a lesson, if you don't have it out during the lesson, you should be looking at it after the lesson and determining, okay, what did we discuss today and what do we need to fill out? Okay, so on continental drift, some of the evidence he had was fossil evidence, right? And I'm going to leave you to fill out the rest of that. So, in the continental drift theory, what was the name of the massive continents that were all connected by small land bridges? All right. So here we have a graphic. If you watch it as it progresses, it shows you in purple the earthquakes, and in that red you'll see the volcanoes, active volcanoes within our planet. It just goes to show that our planet is ever changing. You know, we have volcanoes that are creating new islands all the time. It's creating more land at islands that already exist, and it's also shifting the seafloor to where our continents are going to be moving for the rest of their lives. So this is a really neat illustration. When we're discussing seafloor spreading, I explained to my students, and I'm pretty sure Ms. Kanopic did the same, we discussed that there were how many major plates on our Earth? How many major plates? These are all the plates, okay? I said we didn't need to know the names of them, but you should know how many major plates there are. Okay, we discussed in class plate tectonics, and this is our pre-lab sheet. So we're going to go through this sheet in class. Those of you virtual students, it'll be attached to your Google Classroom so that you're able to answer these questions. Basically, you're going to read this first paragraph up here, and it'll give you the answers. As long as you're reading and acquiring that knowledge, you'll be able to answer these questions. Same way with the second portion down here, okay? So we're going to do that in class. Virtual students, when you're done with this Ed puzzle, go ahead and work on your pre-lab worksheet. Real quick question. Can you name one of the three types of plate movement we discussed in class the other day? One of the three types. All right. So here is the lab instructions, okay? And this is the lab report. It is going to be graded, okay? It is going to be graded. So this is the lab we're doing in class. Virtual students, if you want to do this at home, all you need is graham crackers and Cool Whip. And if you have that, you can do this at home, or you can look it up on YouTube. There are YouTube videos that show someone giving this lab, and you can see what would happen if you're pulling them apart, sliding them, or pushing them together. So you'll still be able to answer these questions if you just go ahead and pull up that YouTube video. The next thing we're going to do is we're going to put some notes in our ISN. This is on tectonic plates. So we have convergent, divergent, and transformative plates, okay? Convergent plates make mountain ranges. They come together and they create those mountains, okay? Divergent plates separate and they create valleys on our on the land masses, and in the ocean they create trenches, and that's where volcanoes come from because it pulls away and makes a thin spot for that magma to come up. And then transformative plates are the most interesting plates in my opinion because they slide past each other like this. And when they slide past each other, they create earthquakes. So for those of you who haven't experienced an earthquake, it's quite amazing to feel everything around you kind of shaking and rumbling, and then you see all of the items in a home. Or my first earthquake was when I was in Las Vegas, and it was in a casino, and they had these giant chandeliers, and you could see these chandeliers swinging back and forth. So we're going to go ahead and put that in our ISNs. Here we have a couple examples of earthquakes that have happened. San Francisco earthquake, they had a great earthquake many years ago, and it caused the great San Francisco fire, and it burned nearly the entire city down. So what type of plate causes earthquakes? Okay, so here you can see that we have the African plate, and at the top it has the Eurasian, North American, and South American plates. And you're seeing the arrows going this way, okay? The arrows are going this way. So what type of plate movement would that be? We discussed about the three. We have one comes together, one that comes apart, one that slides by each other. Which one is this? Which plate? Plate movement. And here we have the third. So if you knew the first two, you should know this one, okay? This is when you have an oceanic crust moving with the plate up against your continental crust, but it's still going to be coming together. What's it called when they're coming together? Like this. What's that called when they come together? What type of plate? Plate movement. All right, we have this additional worksheet that we're going to be doing in class, as well as virtual students. You'll have it attached to your Google Classroom. This is going to ask you questions specifically about plate boundaries, the type of boundary they are, and the type of crustal features you will see. Remember, we discussed in class there are two crustal features. We have oceanic and we have continental. If you remember from class, which one is more dense? Which crust is denser? Okay, in class, we went over this beautiful graphic that Ms. Kanape put together. I love it. It's showing the Earth's core, the magma, and it's showing this heat rising, coming to the top, cooling, and coming back down to the center. What is it called when we have this heating process where it raises up, cools, and comes back down? In my class, I explained that it was the same thing as a lava lamp. So my example was a lava lamp where you have the oil and the water and you have the colored oil. And when that heat lamp at the bottom heats up that oil, it'll rise to the top. As it gets to the top, it starts to cool and it'll come back down. What is the process of something heating up, coming to the surface, and then cooling off and coming back down? We also talked about this the other day. We had the two types of crust. We have the continental and the oceanic, and we discussed how the continental is super thick, but it's not very dense, which I said, think of it like a big sponge, you know, a real thick sponge. And then you have the oceanic that is thin, but very dense. And I said, think of that as a little brick. You know, which one would you want to hit? That sponge is going to be maybe thicker and bigger, but it's going to be softer. Whereas that brick, even though it's a little skinnier, because it's so dense, it's going to be much harder. So what happens is that when the oceanic crust is pushed into the continental crust, you create this subduction zone. It's where they kind of collapse into each other or run into each other. And because the oceanic crust is more dense, it will go underneath or submerge underneath. That's why it's called subduction zone, sub meaning going under the continental crust. When it does that, the oceanic plate is causing that continental crust to buckle up. And so right at the subduction zone, you're going to have a ridge or a mountain or a hill created, and behind it, you're going to have a valley. In my class, I explained that this is how the coast of California was formed. Coast of California, if you go up the one in the Pacific Coast Highway, it has these beautiful ocean views on the left as you're going north, and on the right, you'll see these beautiful mountains. And once you get over the mountains, you have these incredible valleys where they have all the farming. So that's how that was created. So anybody who's been to California and driven up the coast will recognize that. So what types of features are created when you have oceanic and continental crust combining? We just discussed it. What is created? Two things. One thing that's being pushed up, the other one going to go down. So what two features are created by a subduction of an oceanic into a continental crust? The Ring of Fire. There are 452 dormant and active volcanoes of the world located in a region which is 75% of the total number of volcanoes in the world. They're all located in this one area they call the Ring of Fire. You can see the map below. It's the western coast of South America, Central America, North America, goes up along Alaska, and then comes down the eastern coast of Asia and all the way down through the Philippines and Australia. So this Ring of Fire is where the most 75% of the most of 75% of all dormant and active volcanoes reside. So, question is, what's the percentage of the total number of volcanoes of the world that are located in the Ring of Fire? All right, so we have the New Zealand White Volcano eruption, December 9th, 2019. This volcano erupted. This was a place people traveled to see because it was a volcano. 8 people were killed and 34 were injured and rescued, while 8 were missing and presumed dead. It is still active today. So New Zealand, if you didn't know, is a large country that is an island country, just like Australia. And these islands were created by volcanic activity. And they have active volcanoes off their coast that people like to go visit. But what people fail to realize sometimes is how dangerous this can be, because it's still an active volcano and you never know when it's going to erupt again or have some new active lava flows. It happens in Hawaii as well. I'm sure you heard this past year, many people lost their homes due to new volcanic activity where they had large lava flows on certain portions of a couple of the islands. And you just need to be aware of it when you go to visit places like this. So, the last slide. Next class, we'll be continuing to learn about plate boundaries and we'll be introducing topographical maps. So, last question of the day is, what is it called when you have 2 plates sliding past each other? What's it called when you have 2 plates sliding past each other, and what does that create? All right, students, until your next lesson, have a great day.